Now we're on to our first example of finding domains and ranges of functions via graphing. So how do we do that? Believe it or not, it's going to be the exact same concept as that which we discussed in the difficulty 1 examples where we were talking about lists of ordered pairs and the potato diagrams with arrows coming out of them. It's the exact same concept and the exact same thinking that you need to go through in order to solve these sorts of problems. So I'm looking at this function, or this relation, if you like, given by this graph. Not every graph is a function, by the way, so I misspoke. This is a relation. All right. So I have this nice graph here. It's a straight flat line with arrows coming off the sides. That means that the graph is going to continue in that general path forever. So it'll go up basically to infinity and it'll go down to negative infinity. All right. So do I have a function on my hands? Turns out the answer is yes, because every single x value that I could possibly plug in here is going to give me exactly one y value. And that's what I'm looking for. Same concept as before. However, if I were looking at a case like this weird graph over here, where I have this graph that like curves back on itself, if I plug in an x value like right here, and I try to find the y value, it could be in one of three places. It could be here, or it could be here. So in this case, this would not be a function. As I said, not every graph is a function. So I don't know which y value comes out for this particular x value, so that's not a function. However, each x value plug in here gives me exactly one output, or one y value, so this is a function, okay? So what's the domain of this guy? Remember, the domain of a function is the set of all possible x values that I can plug in and get a y value out for. So can I plug in 1? Yeah, sure. It'll give me roughly 1 up here. Can I plug in 2? Yep, because I have a point on the graph just above it. Same thing for 3, 4, 5, and 6. I can plug in each of these x values here and get out a y value on the graph. Okay, so those are all part of the domain. Similarly, if I try to plug in 1.5, I can get a y value. Plug in 1.1, I can get a y value out for that. I can plug in pi, 3.14159, roughly right there, and get a y value out for it. How many different values are there that I can plug into this function? Your answer should be infinitely many. How many infinitely many? Well, the term that we like to use in mathematics is called uncountably many. So we can't just write down a nice list of all possible things I can plug in. We have to write it as an interval. So in this case, I can plug in negative numbers because there's a y value on my graph that corresponds to all the negative numbers. Same thing with all the positive numbers. So for the most part, I can plug in anything from minus infinity to infinity. So I would write this, minus infinity to infinity, as an interval, okay? Any x value that lives between minus infinity and infinity can produce a y value on this graph. All right, so if I wanted to plug in 4, I could just say, okay, what's my y value? Roughly 3. So that's what I can plug in there. Same thing if I wanted to plug in 3.5. Plug in 3.5, it's basically 2. Okay? So that's the domain. It's everything. Another way of writing this would be this nice, sexy R, which denotes the set of all real numbers. And it's just an R with a line going through it. So that's the domain. We got domain now. How about range? Range, as mentioned before in previous videos, is the set of all possible y values that come out of this thing. So what are all the possible heights of this function? Can I get out 1? Can I get out 2? Can I get out a height of 4? Can I get out a height of 5? Can I get out a height of 2.5? The answer to all of those questions is definitely yes, because this graph goes up that high. Similarly, if I want to go in the negative direction, can I get out a height on this graph of -1, -2, -2.5? Yeah. If I want to go even really, really big negative numbers, like -3 bajillion, if that's a number, you can get it. You can plug in an x value that will give me -1 bajillion, right? So in which case, I can get every single y value. There's no stopping point for how high this function can get or how low it can get. So the range is minus infinity to infinity. I can get all the positive numbers and I can get all the negative numbers. All right. As mentioned before, you can write it using this XER, and we have the range. All right. In the next video, I'll show you a more concrete way of finding domains and ranges of graphs. But I want you guys to get into the groove of thinking about what can I plug in, what can't I plug in, what comes out, and what doesn't come out. That's why I went through it the way I did. All right. As I mentioned before, this will be the next example will be a little bit more concrete in how we actually go about doing this. So I'll see you in the next one.